Hello and welcome to another Solana tutorial. Today we're gonna have a look at how we can call random programs. And we're gonna do that by the example of your favorite program, pump.fun. Because everybody loves pump.fun. Except for this guy. Oh yeah, I don't judge, whatever, you do you. And being able to interact with that program is a legit use case that you might have. So today we have a look how you can write your own pumpfun trading bot. Except not really, but we're gonna have a look at how you can send one transaction that does one trade. Low bars. And then you can add your trading bot and whatever you want to build on top of that. And really, even if you're not at all interested in pumpfun, this could be an interesting tutorial for you where you see how I go about deconstructing a transaction. I want to call a certain program, but I have no idea how the transaction needs to be built. Those are the steps that I go through in order to figure out what I need to do to be able to call a transaction. So let's get started. So, hold on. What you could try is ask ChatGPT, hold on, should we try this just for fun in the beginning? Maybe it's smart enough to just, give me the answer straight away. That's not how I usually do it, but I find it funny if it would just, work. Okay, it does not find the pumpfun program ID. We can do that ourselves. That's no problem. That looks good, actually, what it's doing here. The get, although I would do it in the same transaction and not separately, but, fair enough. And then we create a transfer instruction. Okay, and where's that create transfer instruction? This is a USDC transfer. It gives us an example for a token transfer. Yeah. We see that ChatGPT, even though it's smart, doesn't manage to give us everything that we want. So forget about that thing and let's do it manually. So the situation is, client tells me, hey, I want to be able to trade on pumpfun using TypeScript or whatever. And me, I have no idea what that even is. So what do? Well, I investigate. Pump.fun. Just for investigation purposes. This is not an endorsement. Do what you want, but this web page alone is, God, I can't look at it. There is so much moving parts and stresses me already. So what I would probably do is start my own coin and then look what that does. But also, there's so much stuff happening. Ow, what did I just click on? God. Can we go to somewhere that is less stressful? King of the Hill, whatever that is. What I want to figure out is how I can interact regularly. Like here, this looks like what I want to do. So I would go ahead and be like, yeah, sure. I connect my wallet, my hot wallet. Sure, I sign in, whatever. Hot ass. And I have, not a lot in this wallet, so it's not a lot I can lose. So from this 0.01, I want to buy 0.005 sol worth of this King of the Hill. And I place that trade, except I don't actually place that trade. I will just look at the transaction because I ain't approving anything here. So, inspector, what are we doing here? Or what would we be doing here? I can simulate this and it would actually not work because the too much sol required. So maybe my slippage already is too high. Yeah, too much sol required to buy the given amount. Price changed already too quickly for the simulation or whatever. It's fine. So if I would place the trade now, then the transaction would fail anyway. The more interesting stuff comes down here with the actual transaction instructions. Compute budget, I ignore. System program, you transfer to some address that I don't know what it is. Oh, that's Cheeto. Apparently either pumpfun or Solscan decided that I need Cheeto to submit my transaction. Fine. Then another compute budget, we'll ignore that. Then I create an associated token account because I'm getting a new token, so I need to create that. Yeah. And then the interesting part down here, at this program. By now I know this is the pumpfun program, but in the beginning, simply by exclusion, I can be like, okay, that must be that program that I want to interact with. And in the simulation, it tells me instruction buy. So that's already kind of a hint, like it's the right instruction that I want to do, right? I want to buy some tokens. And then in the anchor error log, and this is funny, it tells me program pump. So that's how they called the program. So that tells me, oh yeah, probably that's the pumpfun program. Good. So we figured out the address of the pumpfun program, which is already step number 1. We know which program we want to call. But then how do we call it? Let's actually pump it out of control. On stereo. Okay, so what I would do here is make a new pub key like this. But actually, for this tutorial to be valid longer and just for practice, we're gonna install Solana Web3.js in the release candidate. And then we won't use a new pub key, but we will use address. And that address we import from Solana Web3.js. Let's just check if that works. Seems to work. Cool. So we're gonna use the new Web3.js. I like it. Good, we have the program ID, but how do we call it? How can we do like one of those transactions here, assuming that most of them are either buy or sell? This one was a sell. I don't need to do the transaction myself, right? I can also just look at the transactions that are being called on that program and find one of the ones that I would want to be doing. Let's pick another random one. This one. Somebody's gonna buy something. That's a sell. Oh, that's a buy and a sell. Even better. And here we just have a buy. So that would be the simplest case. Somebody just buys something. We don't really care what. For now, we don't. Because the interesting thing is this part. The pumpfun program is being called with 12 accounts and some instruction data. Now, if we want to call the same instruction, we just gotta do the same thing. Now, what we could do is copy all of those accounts one to one and then send that transaction. Will that work? Well, obviously not, because that would only work if we had the exact same signer as well, and we can't sign for this one. But we could buy our own thing and then do the exact same. So what you could do is you actually buy by yourself, like with your wallet, and then you use the same wallet for your script and see if you can get that to work. In fact, that's actually not a bad approach. I'm gonna do that. Because the next step is basically just building the transaction. How can I build that transaction? So how do you build a transaction in the new Web3.js? I'm not even so much interested in the transaction, more in the instruction for now. How do we build an instruction? Oh yeah, instruction. Program address, this one is quite self-explanatory. We call the pumpfun program. Okay, so far so good. Then we have accounts. Well, that's gonna be more complicated. Those are gonna be those 12 accounts. And then data. Slightly less complicated. What format do you need? A uint8 array. Okay, so coming back to this horrible page, I'll set slippage to, I don't know, 25%, whatever. I placed that trade. Oh, look, now it would actually simulate with such high slippage. This one would actually simulate. I'll copy it, put it here, can simulate it here, and it would still run with success. So this is what we're trying to do. And as the first real simple just task that we do is we just want to build that same transaction as well. So basically what I copied here, I could just deserialize that. That's a base64 encoded wire transaction. I could just decode that like we saw in the previous video on the Web3.js that you find up there. When we talked about the release candidate, we went through an example how to do that. I'm not gonna do it with the base64 string itself. I'm gonna already take a step further and let the Explorer do the decoding and then work with those accounts directly, because that will then make it easier to change later. So the program we're calling is this one. And then basically we have 12 accounts and instruction data that we need to copy. So let's go, maybe start with instruction data. I copy this, I do a new uint8 array of those bytes. Oh, that's hex as well. This stuff is hex. This is deprecated. I don't really care as long as it works. I'm just gonna log that buffer. Yep, we managed to get that data into the buffer. Then we do a uint8 array from that data buffer. And in decimal, it would look like this. Okay, fine, let's get rid of that. We see that it's 24 bytes. Let's do it the correct, not deprecated way. Buffer alloc 24 bytes, and then buffer write this. Same thing. And then we have the data. Good. And if it's structured like that, then we already see a pattern in this data, which is cool. First 8 bytes are completely written, but then here, there are zeros and zeros. So it's very likely that that thing belongs together, and then there's the next thing, and that thing belongs together. Probably even until here. This could be, if it's anchor, discriminator, and 2 numbers. Spoiler alert, that's what it is. It could also be, you know, 2 numbers here and then another 2 numbers here where the second one is just 0. It could of course also be, but always when there are many zeros, it's somewhat likely that it's just a small number used with a bigger data type, like a U64 that just has a small number here. Anyway, we're already making guesses. We don't even need to go that far yet in this first step of just wanting to get a transaction through. We basically just literally stupidly copy one-to-one what we get from this transaction. So one-to-one the data and one-to-one the accounts. Now I will always need to do this, I guess. Now this is gonna be a bit of manual copying work here, because for every account we will need to say what's the address and what's the role. So first account is neither writable nor a signer. We see those here. So we just say read only. And then we do that for all 12 accounts, damn it. That's number 1. Number 2, for now we just blindly copy all of those addresses over as if we're stupid, because we kind of are. And here we already see interesting accounts. This is my wallet. And it's also the signer, we see that here. So that we should maybe also already note user wallet. And then system program, token program, those seem to be static accounts. A sysvar rent, this one seems random again. And this one is actually pumpfun. So those 3 at least seem to be things we know. System program, token program, sysvar. The rest looks a bit, I don't know what that is. Except for this one, because it's also our wallet. And the roles are still incorrect. All of those are read-only, yes. But my wallet, that's a writable signer. This one is a writable signer. And then the 3 above are all writable. And then the second one is also writable. So now we basically just copied the roles and all of the accounts one-to-one. Okay. That's our instruction. And we copied the data also one-to-one what we have here. And then we try to put that in a transaction and simulate it. So how do you build a transaction on the new Web3.js? You pipe like this. Just gonna copy this and just keep the important parts. We create a message. We set a fee payer. We set message lifetime. Then we append transaction instruction. And here we just append our instruction to this transaction. Import all of those things, including the pipe. So our source account, yeah, we will need to get a signer. And here I'm gonna, for now, just use the trick that I saw last time here with the no-op signer with my address, my hot wallet here, why not? And the latest block hash, just gonna copy that stuff from here. I am gonna go to mainnet though. RPC, as easy as 1, 2, 3. Get myself a block hash. Actually, I don't want to send and confirm. How do I simulate? Or is that on the RPC? Yeah, I can simulate directly on the RPC. Okay. So if we then have our transaction, we can say RPC simulate transaction. And we need a base 58 encoded wire transaction. Let's see if we already have that. What do we have? We have a transaction message. So a few steps are still missing. What is missing? The signing, I guess. Not like we're actually signing something here, but types wise, this will work better now. Still not. Okay, you need base 58 encoded bytes. And what we have is fully signed transaction. So something like a transaction encoder, get transaction encoder. encoder encode this signed transaction. Then we put the encoded transaction here. Still not right? Okay. Oh, that's a uint8 array then. That's not quite what I want. Again, I'm a bit stuck with the Web3.js. It's not like I wouldn't know it with the old version, but we want to learn. So that's why I'm doing it so complicatedly. Ah, that's how they do it. Get base 64 encoded wire transaction. Well, easy. Do that instead of that. There you go. Now we have a base 64 encoded wire transaction, and you still complain because you also want a config. Config or a config or a config or a config or a config. TypeScript is not at all helping me here. Maybe I shouldn't have taken the challenge of doing this in the new Web3.js. Damn it. But hey, who am I? A beginner dev or somebody who figures shit out? Neither. What else do you need? I literally don't know what I do here. So that was definitely easier at the old Web3.js. Type stuff. I don't care. Use any fucking config. Can I not provide a config? Okay. All of that is optional. All of that is optional. So the only thing left here is it says encoding base 64. Encoding base 64. That's what you need. Okay, fine. How long did that take me? 20 minutes to figure out how to simulate a transaction with the new Web3.js? Don't do several things at once, kids. Try to stick with the thing that you already know, because otherwise you're getting frustrated, like me. Anyway, so now we have the simulation, hopefully, because I ain't sending that. I ain't actually... What is that? Something is really weird with my TypeScript as well today. This is not... Point is, I'm certainly not gonna actually send the transaction, but I'm okay to simulate it. Transaction is missing signatures. Yes, that's true, it is. There was a thing where I can say set transaction fee payer signer, and then I provide the signer and not the address, and then it should take the signer. It still has the no op signer, so hopefully that would just create a empty signature or something. Oh, still that error, but maybe we're dying later now. Are we dying in the simulation or at the encoding, or where do we die? At the sign. And we can probably also not decode the transaction because that's not a signed transaction. Oh, I mean, it's great that it's typed so strictly, but also it's fucking annoying that it's typed so strictly. If you just want to mess around, it's so much more difficult. Should we just get ourselves the actual signer? You know, it's my hot wallet. I'll just export the private key. All right. Now we have a signer. Don't need that no op signer. Use that signer. And then hopefully this will actually give us a signature. That's better. And then we can hopefully simulate as well. Yes, we reached the simulation. Holy shit, this is taking way longer than I thought. Anyway, so that's already cool. It could like decode that stuff. We are trying to call that program. We are trying to call the buy instruction. So we have the right discriminator. Then we're getting an error of the program expected this account to be already initialized. Well, okay, what's happening here? We are just doing this and we're ignoring that we should also be doing this, which is create an associated token account. So we will need another instruction that we basically copy the same way. We know that program, so we know what those accounts are. And that will also help us to understand what those accounts are. Because we know this is our wallet. This is the account that doesn't exist and that we want to exist. So that's our ATA for the certain token. This seems to be the token because it's owned by the token program and it has that much sol, which is exactly what a mint account has. And then this again is my wallet because I am paying for this. So this guy is paying and this is the new owner of the token account, something like that. So this is both my wallet and this is then gonna be my ATA. So those two accounts, the E3 and the D2, we can then already associate the D2 and the E3. Those will be, so number 3 will be the mint. And number 6 will be my token account. We can already write that here. So number 1, 2, 3, mint. And this one will be user token account. So let's get that user token account in there real quick. Const ATA. And this stuff I'm gonna get from Solana token. Oh wait, was it Solana dash program token, something like that. Ah, there we go. That's better. There we have all of the associated token stuff as well. Find associated token PDA. That already sounds good. First we find associated token PDA. Oh no, maybe that's too low level. And I need to basically relearn everything I learned with the new Web3.js. It's a bit annoying. We gotta do it at some point. Well, let's get a create associated token instruction then with the following input, the ATA. We'll find that at some point. The mint, good point. We'll need the mint. But the good thing is we know it. Oh, it even has the pump in the end. So classic pumpfun mint. Not like I know. Owner will be my signer address, and same for the payer. As we saw here, owner and payer are going to be those. This is going to be the new ATA, and that's the mint. Oh, the payer needs to be the extra signer, sure. And the ATA, how can I... Oh, the seeds is just this. Okay, it's just a weird name. Okay, same mint, owner, again, my signer address. And what else? The token program, well, regular token program. Is this optional by any chance? Nope. Okay, give me a token program. Token program address. Hehe. Cool, and that's the ATA. No, what's the problem here? Oh, we get an address and the bump. Okay, so ATA and bump. No, not like this. Get it in an array. Gotta know that. Cool, so then we get the ATA and we can print the ATA, and then we will see that hopefully our ATA, yes, is the E3 as we already expected that we will need that here. The E3, that's gonna be the ATA. So we're getting closer already. So let's also add this instruction here. So we append both of those instructions and then we simulate it again. Let's see what we get now. Whoa, look at this. Now we get success. Nice. We can actually simulate this transaction. We built that transaction that would actually perform as a trade. If I were okay with sending transactions to the pumpfun program and paying fees to the Fee wallet, then I could do that now instead of just simulating. But I refuse to give pumpfun my money, so I'm just gonna simulate. And you're gonna trust me that that would actually work. Try it yourself if you want. Good enough. That, however, just works for my wallet now with those accounts. Why? Well, because as soon as I change something, the accounts change. So if I want this to work with a different wallet, then I will need to stop hard coding those values here. But that's fine. We can start doing that. The hot wallet, this is gonna be our wallet. So the signer address, right? We sign with this, we can put our wallet here. This one we also already know. This is gonna be the actual ATA. This one is gonna be the mint. And at that point, it should work if I plug in another user wallet. Oh wow, there I have some Sol. I take it. So if I now use my staker wallet instead of my hot wallet, it is also gonna work, the buy, even though the user ATA changed. So maybe I should have let it fail first if I wouldn't have changed that. So let's leave our changes. Then first it would say we're missing a signature for this hot wallet because that we said is a writable signer, but we don't sign for this. So that was the first thing that we had to change. And then once we did change that, it's also gonna complain account not initialized, because once again, it tries to buy into here, but that account doesn't exist. If the account would exist, it would then give us another error that it's not the correct account there. But whole point is we would need to change that as well, such that it's actually that one that we create. And then we get success. Cool. So now it works for a different wallet, but it still doesn't work for another mint. Cause, oh, I need to go back to that horrible site. What if I don't want to buy that one, but a random other Nutella? Don't look, just copy. What if I don't want this as my mint, but this one? It's a different pumpfun token. I exchange the mint here and here. Everything should just work, right? No. We get an error. It says account bonding curve constraint seeds a seed constraint was violated. So we're providing the E8, but it wants an 8N. Okay, so this one it's not happy with. And now we're in the process of deconstructing what those accounts are. Hint, if you find an IDL, maybe you want to use that. And in fact, for pumpfun, there is an IDL. Just Google that. Somebody has created an IDL for it. We would need to check if that's the correct one, like if that's actually accurate. But there we would see all of the instructions, and there's also the buy somewhere where we see all of the accounts with the names and stuff. And we see the third one is the mint, we got that right. And then 3 after the associated user, and then the user, system program, token program, rent. That all seems similar to what we have here, right? ATA, user, system program, token program, rent. So that seems somewhat accurate. However, first of all, we also don't really know what that is. I mean, we can make assumptions, but what is the bonding curve? And the other thing is, maybe there is no such nice thing as an IDL. So how do I still figure out what I need to put here? I mean, great, it's the bonding curve, but what is the bonding curve? We know that for this mint, this was the bonding curve, which for this token already has quite some sol. So it seems to be some kind of address that you sell against or something. And yes, I'm gonna spoil that. Yes, that is the address that holds the sol. If you buy tokens, you send the sol there. And if you sell against that. And this one kind of looks like an ATA. It also has the 2039, which is exactly the size of a token account, because that address also needs to hold tokens. So that's probably where they hold the tokens. So that's probably the ATA for this. But what is this? Like, how do I get there? It's probably that it's the same for every mint, but it's somehow derived probably from the mint. But how? And there it gets possibly very difficult to figure that out. I did it once for a client in the very beginning when there wasn't an IDL and anything. How did I do that? Well, I literally, oh God, I hate that site. I went here and I started searching for account derivations. There's a lot of stuff here. And it's all, you know, encoded in a way that doesn't make it easy to read. But we can search for find program address. Because that's the function name for, you know, deriving a PDA. And we assume that somehow it's got something to do with deriving PDAs. And there's a lot of that. There's something with mint authority, metadata, global. Oh, look, bonding curve. Haven't we seen this before? What's happening here? So it is being, you know, simplified and therefore not easily readable, but because you can't change those names, it's still somewhat readable. So something. Oh, that's how you create one token, apparently. There's probably also the buy somewhere. I might come back to this. Gonna find the dot buy. There. Same thing. Method buy. We have the bonding curve K and the associated bonding curve T. Where does that come from? K comes from here. Bonding curve. And the T is then a function call with the public key and K and false. No, true. And guess what that is? That's gonna be the get associated token account from the old Web3.js. That takes the public key, the mint. So I'm guessing R is the mint. Oh yeah, look here, mint R. We're slowly decoding this. So yeah, the T is the associated token account for the K and the mint. So what's the K now? The K is a public key find program address sync from a static string bonding curve, and the mint R we said is the mint, and S program ID. Let me guess, S is the pumpfun program ID, most likely, because what else would it be? I would assume that it's the pumpfun program ID. So let's try that here. This one, that's the important one. So after the mint, const bonding curve is, oh, how does that work in the new Web3.js? Oh, get program derived address, probably. get program derived address. And the seeds, what type are the seeds? Program address is gonna be the pumpfun program, but the seeds can be, can I put a string here? Just like this, looks okay. And string, and then the mint to buffer, which in this case will be the mint. Can I just take the mint as a seed? I've never worked with this. Again, I'm doing two things at the same time, learning the new Web3.js and decoding pumpfun. So I guess that would be it. You know what? Let's go back to my previous mint and just print the bonding curve and just compare if that would be that thing here. Oh, we're not even executing. Okay. Seed at index 1 with length exceeds the maximum length of 32 bytes. Okay, so you don't like the address as an address. Okay, then I probably need an address decoder or something. Address decoder. Actually an address encoder, because that is the decoded address. And then address encoder encode the mint, which will give me, I don't know, let's just run it. Bonding curve, object promise. Okay, I didn't await this. And now, bonding curve E8M. Bam, 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 bam. Pew, 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 pew. That's how I feel when stuff is working. I mean, trivial, right? Trivial to get this stuff out there. It's not my first rodeo. I've been doing, like, this is, you know, just, you got, I mean, admittedly, very beginners might not get this, but then also very beginners can just copy me and look here. This is how it's done. This is how it's derived. It's just bonding curve and then the mint with the pumpfun program ID. Then we have the bonding curve. And we already made an educated guess what the next thing is, our T, our associated bonding curve. This is gonna be probably the associated token account from that very address. And it's not 0, so it's true, because we must allow the address to be off curve, because that thing is a PDA, so we must allow an off the curve owner. Let's do it. So it's pretty much the same as this, the bonding curve ATA. We find associated token PDA for the same mint, but not for the signer, for the bonding curve. And this will complain. Wait, what is bonding curve? Ah, because we have, again, the actual bonding curve is this. When I was printing it, I should see this. Yeah, so it's the address plus the bump. We are not actually interested in the bump, so we just ignore that as well. Redeclare. Ah, why can't I just do underscores? TypeScript, you are annoying. But that way, this is most likely gonna fail, actually. Not for the reason that I thought. It's not. So this program, apparently this find associated token PDA doesn't care about an allow owner off curve like the old Web3.js did. This one don't care if it's off the curve. That's fine. Okay, let's also log this bonding curve ATA, and we get the bonding curve ATA is 4SJ. Have we seen this before? Oh yes, here, 4SJ. So if we now replace those, because we know that's the bonding curve and that's the bonding curve ATA, then we should be able to put in a different mint. And it should then hopefully also work for a different mint. Let's try. Remove that. Different mint. Let's go. Whoo, look, success. Even for a completely different mint. I mean, I have no idea what I'm doing, but it would work. And those values changed. It's a different bonding curve ATA, also different user ATA, because the mint changed. But we can still create a token account and then call the pumpfun buy instruction, which then does a transfer. Nice, eh? We're getting somewhere. So basically now we're at the point where we can basically do whatever we want, right? Because we basically know all of the things. This is the system program, that ain't changing. That's the token program, that ain't changing. That's the sysva rent, that ain't changing. Oh look, we've also seen this before. This is actually the pumpfun program ID. Do we know why that goes in there? Not really, but it's the same every time, so we can just leave it. Same with this thing. That's also the same every time, and that's also the same every time, and that's also the same every time. We could, if we're interested in, have a look at what those things are. Again, we would go to methods by, and then we would see user. What other things have we not used? The fee recipient and global. Fee recipient, global. Global is R. Where does that come from? R. R is also a find program address sync with global and the program ID. So guess what? It's gonna be a similar thing like this. A global account. I don't know what it does, but it's derived with global. Pumpfun global. What is that? What's the actual address if I derive that? 8F8. Nope, I did something wrong here. R is find program address sync with just global. Oh yeah, just global. I think I still have the mint copied in there. Just global, of course. Boom. Now the global is 4WT. Yes, haven't we seen this before? Yeah, here. This is global. Whatever that is. And we can keep playing that game with all of the things, whatever that address is. What is that address? Can also cheat a bit and see here. Oh, it's the fee recipient. Yeah. What is the fee recipient? Here it's just passed in somehow. Maybe that's just a hard-coded account. I don't know. It certainly, wait, let's check it out because that's fun. It certainly is an account that is somewhat well funded. Lol. And if you also have a look at the tokens, this address owns a bit. It owns a bit of crap. But then if you look at USDC, that's what? How many? Okay, sure, yeah, meh, easy, right? I mean, there's almost no money on there. 280,000 Sol. Yeah, so pumpfun apparently makes good money. Good for them. Good for them. That's where your money goes, by the way, if you trade on pumpfun. Just saying. Partly also goes to other people's hands, but you know. So anyway, I don't want to analyze this more. I can just say, hey, this is just a static address. Maybe it's derived somehow, maybe not. I don't care. I don't think I can change it. I mean, that would be cool. I would like to receive my own fees from the trade. But if I change it, I don't know, let's even, if I were to put the signer address here, it's probably gonna, complain. Oh, yeah, it does complain. Not authorized. Given account is not authorized to execute this instruction. It really expects this very account, my account, it wouldn't work with my account. So I don't know how it is derived or if it is derived, but I know that I must put that address here as the fee recipient. Otherwise, pumpfun is just not gonna allow me to trade. But that's fine, I can just hard code that. Then the last one that is still open is this one, and I don't want to go through the entire process of finding it. It's the event authority. Also, this is somehow derived and I could probably find it somehow, but it's fine if I just hard code that in here because it doesn't change. I would now try it with, different tokens, different things, if it works in all the situations where I want it to work. Or I look at a lot of buy transactions on pumpfun and I will realize that this account never changes. It's always that account. And the last one is always the pumpfun program. So I will just hard code them in there and be done with it. And then that's my final result. That's how you do a pumpfun buy. Oh, wait, no, there's more. Those are just the accounts that we looked at. We didn't discuss yet how much we buy, and that is encoded, most likely, in the data. Where else would it be? And as we discussed in the very beginning, and also as we could probably find here somewhere. Let's go to the buy. Here where it calls the buy, this looks a lot like anchor stuff. So from the methods, the buy method takes two arguments, amount and sol amount. So that's one way to figure it out. The other way, of course, easier. If we have the IDL, we can look at the IDL. What's the actual data of the instruction? That already tells us more. The max sol seems to be something with slippage. But if we don't have the IDL or we don't find that, the other possibility, well, of course you gotta, I don't want, but if I were to actually buy something, I could be like, okay, I'm gonna use a number that is very clear to me that that's my number. That's not a random thing. 1337, and I place that trade, and that I'm not actually placing that trade, but I'm gonna look at the transaction, and I'm now gonna look at the actual instruction data. So I know that I tried to buy 0.001337 sol, in this instruction, can I somehow find the 0.01337 sol? And I'm not particularly good at reading hex, so I'll need to convert that. I'm basically just hex decoding here. Oof, I'm doing something wrong. Okay, let's use a simpler number. 0.000000001. Play straight. For one freaking Lampert. What's the data then? Getting somewhere. Now that's a 1 if I see a 1. But does that mean that this is the amount? Oh, now I get it. Wait, we are buying in tokens directly. And this is my slippage. My slippage says I'm willing to at most spend 1 Lampert. Okay, and this is then probably the token amount, not the sol amount that I'm buying, but the amount of tokens. And that is the slippage. Yeah, that makes sense. So that, of course, depends on, you know, what the market is doing, how many tokens I actually buy for that. Can I switch to token? Yeah, see, that's what I'm going to do. I'm going to switch to token, duh. And I'm going to buy 0.000133 Nope, that's not one. Did you know that all pumpfun tokens actually have 6 decimals? So this will be exactly 1337 with decimals. If I place that trade without actually placing it, but just copying this, going to the inspector, pasting this, analyzing the data, now I have zeros and zeros. So apparently this was so little that it just gives me zeros. Okay, so that's also not working. Fine. Then I buy 1337. Maybe I need more zeros. Okay, fine, because those tokens are worthless. I see. Let's do that trade. See, 1337. Duh. Inspector. Tell me now. What's the numbers? We have some data. So this here is then probably the number of tokens that we buy. And did you notice that this stuff is always the same? Always? Because that's the discriminator of the instruction. You know, you can buy, you can sell, you can create a token. And they seem to use anchor, and anchor uses the 8 bytes discriminators for instructions. And so we can just literally copy this and always have it here on top, and it will be fine. Let's decode this number that we just found. Is this 1337000? No, it's 0. What? 1, 2, 3, 4, 5, 6, 7, 8 bytes. Yeah. Okay. It doesn't like spaces. 1337 with 3 zeros and then another 3 zeros and another 3 zeros, 4 decimals. Because, as I said, every pumpfun token has 6 decimals. You figure that out when you actually work with it. Not like I did. I would never. Unless clients pay me to do it. So, we've got that far. We know that this part of the instruction data is the actual amount of tokens we buy, and this will then be the slippage. And if I say I'm just gonna buy a token with no slippage, well, what do I need to do? Set that to max. Other way around, what will happen if you set it to 0? So let's change this here a bit, because I mean, we know that the first 8 bytes we need is discriminator. Okay, I'll let you keep the first 8 bytes here, keep the first 8 bytes, but then I want to actually write the data properly. So in my data buffer, I write a big int little endian the amount at offset 8 after the discriminator. And then I'm gonna do the same thing for the max sol at offset 16. And now I just need to provide those 2 values. Amount, let's buy, I don't know, what did we say? 13370000000, and the max sol. Let's first set it to 0 and see what happens. Want a big int? Fine. Okay. And we could also look at our data again. Let's run it. See if first of all it even allows that we call the buy. Yep, it allows that we call the buy, but then it fails because too much sol required to buy the given amount of tokens. So that's the slippage that gets us. And if we say, we don't care about slippage, we have all the money in the world, so buy at any price, we can say slippage is max, which is all ones, all Fs. So here we had it at zeros, but I can be like, yeah, I don't care about slippage, I just want to buy. And then I'll be like, big int, can I do -1? No. How do I do this in TypeScript? In Rust, I would say U64 max value. Do you have something like that? Oh, it's even a big int is even signed. I can't even. But then I can be at -1, no? -1 is a valid big int, right? And then we write it as, actually I should have already done this here, as an unsigned integer. We should write unsigned integers, let's be honest. But we write a negative number and then it should be the max value. Let's check this. Oops, still out of range. What? Okay, fine. Then write your integer. I don't know, whatever. There we go. That works. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All 255s, all Fs in hex, max slippage. We don't care about no money. We just want to buy them tokens. And in reality, you would want to set a proper value here that you probably somehow, I don't know, find out what you're willing to pay at most. But yeah, that's the slippage setting. And that's the actual amount in tokens that we buy. And now we can configure basically everything because we have the amount, our slippage, we can specify the mint. It's dependent on our signer, so we can, you know, use whatever key pair we want. And the cool thing is, it actually simulates successfully. Does that mean it actually works? Of course it does. I don't need to prove that to you because I ain't paying no fees. Okay, fine. Let's buy a freaking token on pumpfun. You have trust issues. You don't believe me anything. But I ain't spending my $20. We're going back to my hot wallet. And then, okay, fine. We're gonna send and confirm transaction. The signed transaction. And commitment confirmed. We await this. What do we get? Do we get a signature? What do we get here? Promise for void. Nothing. We get nothing. Okay, fine. We get nothing. Then, cool. Transaction sent. And I'm gonna print myself the signature as well. From the signed transaction, signatures. What is this? It's a signature map, signer dot address. That's how you get the signature. We're sending transactions now. Is that what we're doing? Okay. No. Actually, first let's wait. We wanna first find the right values. Wait, what token are we actually gonna buy? This one? Looks like a rug, but then again, everything looks like a rug. Even this rug. I don't want to buy any of that crap. Why are you making me do this? A cat. Oh, look, it's going up. Quickly, buy. For 0.001 sol. We get 5,000 love. Place that trade. That would actually work. But we're not gonna do it. We're just testing values. So this is the amount that we buy. So that's the amount. Wait. No, that's the sol amount. The amount we wanted in tokens was 5,000. 5,000 love with 123 decimals, 6 decimals. We don't care about slippage. They're gonna rug us anyway. And this is the token. So that is the mint. And with that, we should be set. Would that simulate? Yes, it would. And just so you believe me that it actually freaking works, let's actually freaking send it. Just proving I don't have any tokens in my wallet. Pump it. Out of control. Simulation works. Transaction hits the cluster. We don't have any priority fees or anything. We will see if we can actually trade without priority fees. Possibly not. I didn't add any, like I didn't intend to actually trade. Just simulate is fine. Yeah, nice. I'm not particularly happy with how I formatted my signature, but never mind. Point is, we have 5,000 love now. Love. We can totally buy pumpfun tokens, and we could probably also figure out how to do the sell by going through the exact same process, but not today. And for me, not ever. Enough. I hope that you could follow my process of what steps I go through to be able to call any program. Yes, some programs are difficult to deconstruct. Some of them don't want you to call them, so they don't provide you with the IDL. I don't know if pumpfun themselves provided the IDL or if somebody created it. They do have an incentive for people to actually trade because they profit from it. They did profit from me as well. Yeah, I'm totally making them rich. Anyway, so not every program will make it easy for you to call it. And another note, if you don't know what the program does, maybe you don't want to call it. But if you do, and you just want to build your application on top of that, like have a better UI than whatever that is go away. Then you can, build your own UI for it, or even build your own program that calls that program. That's the same process. You'll also need to do this, just that you build the transaction inside your program and CPI into the other program. It's the same idea though. You first need to understand what accounts and what instruction data you need. Yeah, and I hope that you got an insight into my thinking process of how I do those things. It's not that difficult if you know how Solana works and have a bit of an understanding of data types and stuff. But that said, it's not possible everywhere. It might also be impossible for you to figure out how to derive the accounts correctly and stuff, because if the devs don't show, then it's just difficult or impossible, because just from having the derived accounts you can't find the seeds. It's not possible everywhere, or they might have random rules that you can't figure out. But if the program is not making it extra difficult for you, if they want you to call it, then you're usually able to figure it out somehow. And I hope that this video helps you understand how I do it. Okay, that's enough. I spent a lot of time on this because I did use the new Web3.js just to get some practice, because then we will be using that a lot in the future. And yeah, it's good. We are able to call a random program that we don't have the source code from. Oh yeah, if you have the source code from the program, maybe I should have mentioned that in the beginning. Read the source code and then call it the way you know. But I don't have the pumpfun program source code. It's a late notice, but that's you should think about that as well, now that you understand how you would do it without the source code. And IDL is the next best thing if you don't have the source code. And even better than that, ask the dev. But I don't know who the devs of pumpfun is, so I can't do that, right? You can ask this dev for help if you need anything, but this dev is not gonna do stuff for free, just saying. And also this dev has a lot of work with all the videos that he's making and all the other things that he's doing that he might not be available, but you can always, check in if I have time for some contracting work. I might, if you can pay me well enough. Because I ain't doing that shit for free. Except this time I did. Several months after I did it for a client who paid me for doing it. I did this before, in case you couldn't tell. I kind of already knew it. I just went through it again. And hey, if you have a program that you want analyzed, I'm up for the challenge. Like, I could do it live. Let me know what programs you're interested in. Are there programs that you want me to have a look at, how to call them? Maybe I'll do that in a future video, because I need to practice that stuff anyway. And to a certain degree, it's also fun. And to another certain degree, it's also frustrating. But the more frustrating it is, the better I feel afterwards if I actually managed. And today we managed. Yeah. Okay, good enough. I shall do something else that is not trading related. I'll go dancing. And you, go watch those videos, like and subscribe, and then I'll see you in the next one. I gotta get out of here. I wanna get out. It's hot. I just gotta. I'll see you in the next, and I'll be around, but that's just whatever. Bye.